take a look at these two graphs. We have a line on each graph, this blue line and this green line. Notice that they're completely different. One goes up, one goes down. The green one goes down more steeply than the blue one goes up. The difference in the comparison of the change in y with the change in x, okay, these differences we call slope. All right, let's talk about this in a little more depth. Let's say we want to quantify, okay, we want to come up with a number that can represent, so we can look at the number and know whether the graph is going to be going up or down, or how steep it is, etc. Okay, so we have some ways to do that. One way that we like to think about it is we'll take a point, or actually 2 points, on a line. So let's take these 2 points. This first point is the point 1, 6, and the second point is the point 3, 9. Okay, we'll take these 2 points and we will compare them, okay? The way we compare them is we compare the difference in the y value, okay? So how much did the y change? Grab a highlighter here. The y changed this much, right? And then we also want to look at how much did the x change. The x changed this much. So we want to come up with a way to compare, or actually take a ratio of how much did the y change and how much did the x change. So we call this slope, and you've seen this before. We say that m equals, and m is slope, okay? M equals the change in y divided by the change in x. Alright, and you probably have noticed that mathematicians like to shorthand things. So instead of writing out change in, we usually use the Greek letter delta. Okay, so this delta just means change in. The change in y divided by the change in x. Okay, it's just a little faster way of writing it. You'll see it in science. Okay, so change in. And so in this case, what is the change in y? We start here, we go up to here, we changed from 6 to 9, three places, right? Okay, so we go up 3 places. And what about the change in x? It goes from here to here. Okay, that is a change from 1 to 3. It's a change of 2 units. So in this case, we get 3 halves as our slope. Okay. And this is a positive number, which tells us the line is going uphill. This slope would be a negative number. And this slope has a smaller absolute value than this one. This slope will have a very big absolute value, which means the line is steeper than this one. All right. The closer the slope gets to 0, the more horizontal the line is. The farther away the slope gets from 0, the more vertical the line is. All right. Okay, so what about, let's talk about some different features of lines real quick. Okay, so one thing is the Y-intercept. The Y-intercept is where it crosses the x-axis, okay? I mean the y-axis, I'm sorry. And this point right here is the point 0, 5, okay? And over here you can't see the Y-intercept, but it'll cross somewhere down here, all right? So from this, the Y-intercept, and from the slope, we can come up with formula for slope, okay? What did we do here to find out this slope? We took this y and subtracted this y, And on the bottom, we took this x and subtracted this x, and that works as a formula always for slope. You can take the two y's and subtract them, and take the two x's and subtract them. And we're going to use this formula for slope along with the y-intercept and come up with a form for an equation of a line. Okay, so let's say we have the formula for slope, where we subtract the two y's to get the change in y, and then in the denominator we'll subtract the two x's to get the change in x. Okay, and let's say we have the y-intercept. The y-intercept, and I'm going to use an arbitrary y-intercept. Okay, it's going to be the point 0 something. Okay, and usually we use the letter B for y-intercept. All right. So let's go ahead and say that we have an arbitrary point that we're going to call x and y. Okay, so we're going to use the variables x and y as our second point. Okay, let's plug them in. So this will be the first point, this will be the second point. We'll plug them in here. M equals y2, the second point, which we just called y, minus y1, which is b in this case, divided by x2, which is just x, minus x1, which is 0. Okay, now let's solve for y. So first of all, x minus 0 is just x. Okay, let's multiply on both sides by x. That way it comes out of the denominator. Okay, and let's add b to both sides. All right, notice something? Does this look familiar? This is called slope-intercept form of a line. Okay, so if you know the line's slope and the line's y-intercept, you can plug this in and leave y as y, leave x as x. There are variables. Just plug in m and b, and you will have an equation for your line, given any arbitrary point. Okay, let's do the same thing again, but this time we're going to use, instead of the y-intercept, we're going to use a random point. Okay, so new page. Let's say that we have the slope again, and the slope form, y2 minus y1 over x2 minus x1. Okay, and this time we're going to have a random point, and it's going to be x0 or x0, y0. And then we still have our variables x and y. Okay, we're going to do the same thing. This will be our first point, this will be our second point. So we'll plug them in. M equals y2, which we call y, minus y1, which we call y0, x2, which we call x, and x1, which we call x0. Okay, so similarly to last time, can we multiply on both sides by this denominator? That way we can get it out of the denominator. M times x minus x0 x naught equals y minus y0. Okay, and then let's add y0 to both sides so we can solve for y. Okay, so y0 plus m times x minus x0 equals y. Alright, and this is called point slope form. And if you notice, okay, so this is another form for a line. Y equals y0 plus m x minus x0. And the reason it's called point slope form is because you can plug in your slope, but instead of plugging in the y-intercept, you plug in any random point, okay? So we have our variables y and x, we have our slope, and we also have this point, x0, y0. And so we have this other form for a line.